Alrighty. So, like I said, we're going to be talking about equations and solutions and solving, which means we need to know what those things all mean. So we have been dealing with a lot of expressions, and we need to think about what's the difference between an expression and an equation. Just think about that for just a second. Sweet babies in there. Awesome. So an equation, what we're looking for here, it's something that has an equal sign. Oh, that's a chunky pen. So an equation, the way we word this is two expressions set equal. So expressions are something like 2x plus 3, or 7y minus 4, or 3, or 2, or 0. Those are all expressions. So if I put an equal sign in between two of them, I've magically made an equation. Thanks, Jaden. Did you get one?
Yeah.
Okay, then it should show up in Skyward. I was like, you're close enough. You didn't like get the kiosk pass and then go wandering. Just double checking what I got in there. Sweet, you found it. And it's in the system anyway, and it's 7:18, so I know you didn't go wandering, making silly choices. Okay, so it's just two expressions set equal. When we say to get to a solution has several names. We can call it the root. It's sometimes the intercept, but it's always an intersection. Basically what it is get to x equals, or y equals, or if we have both, x equals and y equals. Ooh, snap. In this particular chapter, we're going to have a lot of solutions being a point, x, y. So we're going to be finding a lot of intersections, so equations and where they cross. And solving, that is just the process of getting to that solution. The way we solve is we do the same operation. Like, add, subtract, multiply, divide, that kind of stuff. That's the operation I'm talking about. We're not getting medical degrees. On both sides of the equal sign. To get to a solution. The goal is to get to our solution. So we're going to be doing a lot of solving. This chapter is all about finding solutions. So we're going to start out with just solving an equation, finding what x is. Okay. Ready? So I've got 4 equations up here. We're going to practice this and make sure we can spot all the pieces we need to do. So we've got x plus 4 equals 5. What can I do to get x by itself here? Minus 4 from both sides. There's my stylus. Found it. So if I come in here, I can minus 4 from both sides of my equal sign. That's going to give me that x equals 1. As long as I do the same thing to both sides of the equal sign, I can do whatever the heck I want. -4 is the most helpful. But I can do whatever I want. If I start like multiplying or dividing stuff, it's going to get fractiony and weird. But I can do whatever I want. Just -4 is the most helpful. So let's look at the x minus 3 equals 5. What can I do here? Add 3. Good job. Okay, hopefully this is a little familiar. So we get that x equals 8. 5 plus 3 is 8. And this is our solution. On the first one, this was our solution. I'm just going to get a little, just so we can tell which things go where. Oop. All right, what about 2x equals 4? What can I do here? Divide both sides by 2. I'm just going to put it as a little baby fraction like this. However you feel like notating it is fine with me. I do not care. When I divide both sides by 2, this 2 and that 2 cancel out, and the right-hand side simplifies down to be x equals 2. And x equals 2 is our solution. Last one, we always get a little scared when we see fractions. How do I get rid of a fraction? Multiply by what? 2. Specifically, whenever we have any fraction, ever, if you want to get rid of them, multiply by what's on the bottom in that denominator. So I'm going to multiply both sides by 2. This 2 and that 2 cancel out. If you multiply by what's in the denominator, the fractions will leave. So we're going to have x equals 14. They are going to get harder than this, just so that we're aware. But it was just reminding us of our operations that we have used a gazillion times. That we just need to remember. Okay. Questions on any of these 4? Awesome sauce. Kick it up a notch. We're going to start combining stuff together. So we have 3 times the quantity x minus 2 plus 15. When we are working with more than one operation, kind of easiest we work from the outside in. Start with the stuff that's outsidiest. So in this case, my x is inside of parentheses, so I want to deal with that 3 first. What are we going to do to get rid of that 3? Divide. Because this 3, this 3 is being multiplied. There's an invisible multiplication right there. So if I divide both sides by 3, this 3 and that 3 cancel out. And we're left with x minus 2 equals 5. Are the parentheses doing anything for us anymore? No, so we can get rid of them. If there's nothing outside our parentheses anymore, they have done their job and we can be rid of them. Then what do we do to get to our solution here? Add 2. Okay. We've got to blow the dust off of the mental shelves where we solved stuff. Because I know we've done it before, but it's been pushed way in the back of the storage shelves. Dust boxes, leaf litter, whatever we got up there, stuffed animals, squishmallows are piled on top of the how to solve an equation. And we got to clear everything off and bring it back forward. Okay, gets a little more complicated on this one. And we have 1/2 times 5x plus 4 equals 12. So again, look at our side that has our x and start by the outsidiest thing. Multiply by 2. We multiply by whatever's in that denominator. And whatever I do to one side, I have to do to the other. This 2 and that 2 cancel out. And we're left with 1 times 5x plus 4. Equals 24. If all we have is that 1 outside in the parentheses, are the parentheses doing anything for us? No. Because 1 times anything is itself, and so there's nothing multiplied outside. It's not making any dang difference. So now we're here. What can I do to figure out how to get x by itself? Minus 4. So we're left with 5x equals 20. Divide by 5. And we get that x equals 4. If any of those steps you need to put it in the calculator, that is 100% valid. You do not have to do this all with mental math. Doing it with mental math will save you time, but only if we're right. Okay? So feel free to double check any of the calculations in the calculator. Shoot, we got calculators that live in our pockets anymore. Utilize them. Okay. Questions on these ones? Because the next one looks really scary. The next one is the first one the book wanted you to do. They wanted you to hop right into this, which is a little intense of a way to start. So I've got x's all over the place. I got fractions. I've got big numbers. I've got small numbers. I've got negative numbers. There's a whole lot going on here. So we have 1/3 times the quantity 2x minus 57 plus 1/3 times the quantity x minus 6 equals negative 4. So we see fractions and we go, ew. We do not like fractions. So I already heard it once when we were starting to look at this, and our first instinct is to multiply both sides by that denominator.
Can't you do by 6 at the same time?
We actually don't need to do by 6 to save time. If we multiply both sides by 3, you have to multiply the whole side. So if I multiply this side by 3, think of it like distribution. This 3 times this piece, and this 3 times that piece. That purple does not show up there. There we go. If I multiply by 3, I'm going to write it out long way. So we're going to have 3 times 1/3 2x minus 57 plus 3 times 1/3 x minus 6 equals negative 4 times 3. I'm just writing out the multiply by 3 step. If I multiply both sides by 3, it's hitting both pieces. So this 3 cancels out with that 1/3, and this 3 cancels out with this 1/3. So we're left with 2x minus 57 plus x minus 6 equals negative 12. That feels like a big jump. So you got to remember, when we multiply the side, we multiply every piece of the side. Every addition gives us a new piece. Questions on these 3 steps, because these are a little intense. It's a little intense. Okay. What can I do here? Combine like terms. Put my x's together, put my numbers together. So I have 2x plus x, which is 3x. And I have minus 57 and minus 6. Negative 63. equals negative 12. Oh, no, negative 51. No. Negative 63. Love it. I made a mistake on mine. Sweet. Good to go. Then what? Add 63 to both sides. Now I'm trying to get that x by itself. We're left with 3x equals 51. Divide by 3. What is our solution here? Type it in a calculator, y'all. 17. So these are big beasties. We're working from the outside in. Questions on this one? Technically, we'll have 2 more problems. But one of them is the story problem. So you got that the diameter of Earth is 828 kilometers less than twice the diameter of Mars. If we know the diameter of Earth is 12,756 kilometers, what is the diameter of Mars? So the first things we need to figure out, what the heck are our variables? What don't we know? Mars. So we're going to say, I'm going to use M equals Mars. And this is a table that's in your book. You don't have to write this table out. It's just kind of dividing the sentence into chunks. Because what we're trying to do is we are trying to figure out what our equation is so that we can solve it. So they pulled out this sentence here that is kind of the key sentence. We've got that the diameter of Earth is 828 less than twice the diameter of Mars. So what's a piece in there that we can spot to put into math terms?
Is it listed?
We're not going to do less than. It's going to be an equation. But I like the thought.
M equals 828. Oh, wait, no. 2 times 12,756 minus 828.
So the way you're doing it is fine. It's just not structured the same. So the way you're doing it's fine. Your instinct's good. Okay? So what I'm going to do is I'm going to take the exact words we have here. Twice the diameter of Mars. Right? How can I write twice Mars if I don't know what Mars is? 2, yeah, or 2m if we're going to use m as our variable, right? Or 2x is totally fine. How do I say 828 less than that? 828 less than that. Yeah, we're going to subtract 828. What is the diameter of Earth? 12,756. That's this guy right here. If I take the word is into an equation, what's going to go right here? Equals. All right? So if we're just straight up struggling to find an equation, find your sentence and break it into chunks. Twice the diameter of Mars less 828 is that. It's like running translation in a foreign language, translating words into math. Because those two pieces mean the same thing, that the diameter of Earth is 828 less than the diameter of Mars, and 12,756 equals 2m minus 828. So let's figure out what the diameter of Mars is. What are we going to do to solve this? How do we get m by itself from here? Add the 828. So I need another color. Let's see. Let's go with orange. So let's add 828 to both sides. And we're going to get that 2m equals 13,584. Use a calculator, y'all. It's all good. No shame in that calculator game. How do I get m by itself? Divide. By what? 2. Why won't it let me see? My thing frozen? There we go. Now it's thinking. There we go. So divide both sides by 2. We find out that Mars is how big?
6,792.
So if we were to put that in context, we would say Mars is 6,792 kilometers. So it's all about finding the sentence that has your math and finding each of the individual pieces. We have one more after this. And it's not as gross as this. It's not a story problem. Maybe it is gross. Questions on this one. I feel like story problems are where we struggle the most. And that's totally normal. Totally normal. That's why I practice story problems, because that's where a lot of people struggle the most. So, oh, we already did that part. Good for us. All right, so for our last one, we're going to do something called a literal equation. It gives you all kinds of context here. This is, again, from your book. It's the formula for perimeter. 2a plus 2b equals your perimeter. The sides, the legs, whatever. And what we're told to do is solve for b. That means my goal is to get b all by himself. I want to get to b equals. If it says solve for b, then we're aiming for b equals. The other side can be a hot mess, and it sometimes is a real hot mess. And that's okay. As long as it's b equals whatever your hot mess is, we're there. So what can I do to get b by itself from here? Yeah, I need to get this 2a to leave first. It's farther away than the b. So if we subtract 2a from this side, I need to also subtract 2a from this side. So we're going to have p minus 2a. Do not make it negative 2a times p. Like, we're just subtracting. That's a common mistake I see. Equals 2b. How do I get b by itself? don't care what's over here. I want to know how to get b by itself.
Over 2 divided by 2.
Divided by 2. I need to get this 2 away from the b. So we're going to divide this side by 2 and this side by 2. So we're going to have b, bless you, equals, because those 2's cancel.
1/2 p minus a.
Careful. Yes. I was going to say don't lose the p. You can absolutely split it and simplify it. Just like we did over here. P over 2 minus 2 over 2 cancels, or 2 over 2a. You can do it like this, or 100% leave it like this. Totally fine. It's the exact same thing. P minus 2a all over 2. The only benefit to this one is that I can simplify this and make it minus a, because the 2 over 2 cancels out. So that is the only benefit to splitting it. They're legitimately the exact same thing. Legitimately, and I do not care how we put it. So this is fine, and this is fine. Both are pretty, okay? I don't care how you put it. Questions on this one? It looks like a lot up here. So I'm going to give you the 2-1 worksheet. Again, I still have the book numbers up here. Don't do both. I've had a couple of people do that. It's the same stuff. Like, I take the book problems. Sometimes I change them a little, but they're the same thing. They're the same thing. Okay? So, I'm going to pass out 2-1. If you guys have it. It's going to be the same homework tomorrow. So, there's going to be stuff on here that you don't know how to do. Most specifically, 9 through 12. 9 through 12 is what we're going to talk about tomorrow. But, yeah, 1 through 8, you can absolutely try and do. Okay? So you guys have 15 minutes before the announcement starts. So you can start on this and then have, like, significantly less to do at home. Okay, so work on stuff, ask questions. Like I said, I'm about halfway through grading the quizzes from yesterday.
1 through 8.
They didn't seem awful. I've had at least 100%. Some of them were not great, but I'm pretty sure those people didn't really try on the homework either. So we'll kind of see how it goes. I should be able to get them in tonight. Maybe late tonight, but tonight. Okay?